Welcome. Today, we are going on a mission. Our objective? To crack a secret code. You know, a language that can seem super baffling, a little mysterious, and, let's be honest, downright tricky. I'm talking about algebraic word problems.
You know exactly what I'm talking about, right? You're just staring at this block of text, and it feels way more like a riddle than a math problem. But what if that's the key? What if we start treating them that way? Not as something to be afraid of, but as a cool puzzle just begging to be solved. Because that's the real secret. There is a system, a method that can turn all that confusing word soup into a clear, simple, and totally solvable equation. Think of it like a master key. And guess what? Today, I'm going to hand it right over to you. All right, so let's get right into it. We're going to call this our 5-step decoder key. And it's awesome because it's a universal method that breaks the entire process down into these small, logical, easy-to-handle steps. No more guesswork, no more just staring at the page, just a clear path from the problem right to the solution.
So this is it. This is our key. First, we just scan the message, read the problem carefully. Second, we figure out what the big mystery is. We identify the unknown. Third, we translate the words into math. Fourth, we crack the code by actually solving the equation. And then, and this is super important, step 5, we verify our solution to make sure we got it right. So let's put this key to the test.
Okay, agent, it's time for your first assignment. We're calling this one the case of the missing number. It's a total classic, which makes it the perfect training run for us to try out our new decoder key. And here it is, our first coded message. Now, it might look simple, but trust me, it's got all the pieces we need to practice our method. Our one and only goal is to find that mystery number. So step 1, scan the message. Well, that's easy enough. We just read it. Now for step 2, identify the unknown. What's the thing we're trying to find? The problem tells us straight up, find the number. In algebra, we just give that mystery a little placeholder. We'll call it x. So from now on, x is our mystery number.
And now for my favorite part, step 3. Translation. This is where we turn the English into math. A number? Well, we just decided to call that x. The phrase decreased by 7, that's just a fancy way of saying -7. And the result is 9, that's just code for equals 9. See? It's like a direct translation. So, when we put all those little pieces together, that whole sentence boils down to one simple, beautiful equation. X minus 7 equals 9. The code has been translated. Now it's ready to be cracked.
Let's get to the fun part, step 4. We gotta find out what x is, which means we need to get it all by itself. Right now, 7 is being subtracted from it, so to undo that, we do the opposite. We add 7. And the golden rule of algebra? Whatever you do to one side, you've got to do to the other to keep it balanced.
And look what happens. On the left, the -7 and +7 cancel each other out, leaving just our x. And on the right, 9 plus 7 gives us 16. There it is. The missing number is 16.
But hang on, we're not done yet. A really good codebreaker never ever just assumes they're right. They verify. This is step 5, and honestly, it's what separates the pros from the amateurs. We have to check our answer.
So let's just plug it back into the original message. Is our number 16 when decreased by 7 equal to 9? Well, that's 16 minus 7. It's 9. It checks out perfectly. Mission number 1 is a success.
Feeling pretty good, right? Awesome. Let's level up. For our next mission, we're going to see how our decoder key works on a slightly tougher code. Yeah, this one's got fractions, but don't even worry about it. The system works exactly the same. Okay, here's the new intel. We've got 2 people, Ned and Ben. We know their travel distances are connected, and we have a hard number for how far Ned went. The big question is, how far did Ben go?
All right, you know the drill. Steps 1 and 2. We've read the problem. Now, what's the one thing we're really trying to figure out? The last sentence gives it away. How far did Ben travel? So let's call that unknown distance D this time. Okay, let's fire up step 3 and translate this thing. The distance Ben traveled, that's our D. Now, here's a super useful tip. The phrase 1/4 times of the distance means we're going to multiply. That little word of almost always means multiply in these problems. So that's 1/4 times D. And since we know that's how far Ned went, and Ned went 12 kilometers, our equation becomes 1/4 D equals 12. Time for step 4. Let's crack this code.
To get d all by itself, we need to get rid of that 1/4. Well, multiplying by 1/4 is the same as dividing by 4. So to undo it, we do the opposite. We multiply both sides of the equation by 4.
And what happens? On the left side, the 4 and the 1/4 cancel each other out perfectly, leaving us with just d. And on the right, 12 times 4, that gives us 48. So Ben traveled 48 kilometers.
But you know, we're not done till we do the final check. Step 5, verification. The original story said Ned traveled 1/4 of Ben's distance. So, is 1/4 of our answer, 48 kilometers, actually equal to Ned's 12 kilometers? Yup, 1/4 of 48 is 12. The code is cracked, case closed.
Okay, let's just zoom out for a second. Think about what we just did. We solved 2 totally different problems using the exact same 5 steps. That is the real secret here. It's not about trying to memorize a million different types of problems. It's about having one solid system that you can trust every single time.
So, what's the big takeaway from all this? First, it's about changing how you think. These things are puzzles, not threats. A variable like x or d isn't scary. It's just a placeholder for a clue you haven't found yet. And most importantly, this 5-step method isn't some cheap trick. It's a real, reliable system that gives you the power to translate regular language into the powerful language of math.
So now you have the decoder key. And that kind of makes you wonder, doesn't it? This whole process of taking a big, confusing problem and breaking it down into small, logical, manageable steps, that doesn't just work for algebra. So the real question I want to leave you with is this. What other complex codes in your life could you crack just by applying a simple, logical system?